Hey guys, we're up to 9C, which is isomorphic connected graphs and adjacency matrices. So we're going to look at each of those three things. Firstly, we'll start with isomorphic or equivalent graphs. So isomorphic will mean equivalent in this case. And they're graphs that look different, but they actually have the same info. So if we look at this graph here, obviously it appears a certain way. But what I might do over here is I've put all the vertices except for B in the same spot. See how B's up here? I've dragged B from being up here down to here, but then I'm going to connect each of the vertices with the same edges. So that one's going to remain there. D and C connect, so that'll go there. A and C connect, so that bit's sort of in the same spot. But because B was dragged down, B and C still connect, and B and D still connect as well. See how these two networks or these two graphs, they look different, but they have the same information. So like A and C still connect, B and C still connect, D and C still connect. All the connections are the same, all the edges are the same. It's just that I've moved one of those vertices to make it look a bit different. But these two are equivalent, which means they're isomorphic. Now another one, this one here, now this looks even different again. This one's also isomorphic to these two. It has the exact same connections, it's just the vertices have been moved to make it appear a little bit different. Okay, so again, the main thing is isomorphic graph means they have the same information, but they look slightly different because the vertices have been sort of moved or rearranged. Now, you're going to be asked to check or to see if two graphs are isomorphic or not. So I just want to look at this bit here because this is a bit of a tip in terms of how to work that out. So you can check if graphs are isomorphic by listing the number of vertices, labeling edges, and finding the degree of the vertices. So we've got two graphs here. I want to see if they're isomorphic or not. So I've set up all these things that we can kind of record just to see if they're the same. So V is the number of vertices, E is the number of edges. We might list the edges as well, and then the degree of each of the vertices as well. So I'm going to start filling all this stuff in. As soon as we recognize that there's any difference between the two, that would mean that they're not equivalent. They're not isomorphic. So let's just make a start though. All right, so the number of vertices in this one is 4. Number of vertices in this one's also 4. Awesome. The number of edges, we've got 1, 2, 3, 4, 5. And this other one we've got 1, 2, 3, 4, 5 as well. Except, let's see if they're the same. We've got an AD here. That's how you'd label an edge with the two vertices that it connects with. So there's an A, well there isn't an AB, so that should be AD. Okay, so there's an AD, there's an AC, there's a DB, there's a DC, and there's a CB. There we go. So we've labelled all 5 of those ones. We can label these ones too. So this one has a CA, it has a AB, it has an AD, it has a DB, and a BC. There we go. So they've both got 5, but let's see if they're the same. I don't think so, because it looks like this one, see how C has 3 connections there, 2 connections there, and it has 3 here? It doesn't look like they're the same. So even though we have 5 edges, they're not the exact same edges. And we can check by looking at the degree of each of these vertices as well. So A is degree 2, B is 2, C is 3, and D is 3 as well. Let's have a look at this one. A is 3. Well, there we go. We can already see that they're not the same. Okay, so as soon as you notice any difference, they are not the same, they're not isomorphic. Let's move on and have a look at connected graphs. Now this is a nice easy one. Connected graphs are when no vertices are isolated. So we've got a graph here and a graph here. Can you see with this one how C is not connected to anything? So that means it's isolated, it's away from everything else. So this one would be not connected, whereas this one, none of the vertices are isolated. See how they're all connected together? So that means this one is a connected graph. Now the last thing that we'll look at is adjacency matrices, and this is one of them. This is an example, and it shows how many edges connect vertices together. So let's just use this one and kind of read it just to see what it means. So this spot here, you see how A and A are lined up? That's telling us how many edges connect A and A together. This one here is telling us how many edges connect A and B together. See how B and A line up? This one here is telling us how many edges connect A and C. And the same thing all over. What you'll notice is there's 2 spots for each one. So you see how this one shows that A and B connect twice? There's also one over here. So A and B, they connect twice. Okay, so we need to make sure we're getting both of those spots correct. Now the last thing we're going to do here is we're going to make one of these adjacency matrices for this graph here. All right, now let's just start filling this in. I've set it up already. So how many lines or edges connect A and A? There's none that are leaving A that go back to A, so that would be 0. All right, how many edges connect A to B? A to B, it looks like there's just one line going there, so we can put in 1. There's one line. How many connect A and C? Well, there's 1 and there's 2, so there's 2 that connect there. And how many connect A and D? A and D, 1 line goes there. Done. All right, now again, let's go down this column and fill the same thing in. So how many connect A and B? We already worked it out before, that's 1. How many connect B and B? None. None leave B and come back to B, so that'll be 0. How many connect B and C? Doesn't look like any go from B to C, so that's 0 as well. And how many connect B and D? So there's one line that goes from B to D, so that'll be 1. Let's keep doing the next one. How many connect C to A? C to A, that's 2. How many connect C to B? That's 0. How many connect C to C? 0. And how many connect C to D? None go from Z to D. There we go. And the last column, how many connect D to A? Looks like there's 1. How many connect D to B? Looks like there's only 1. How many connect D to C? There's no lines that go from D to C. And how many connect D to D? So we see how with D, we've got a loop here, so it leaves D and it comes back to D. So that means we've got 1 there. Okay, so now this adjacency matrix, it shows us the connections of this graph here. So you'll be asked to fill in a few of these based on information like that.